Hello, this is Mr. Stansbury. I'm going to take you through the notes on independent events. At the end of this, you should be able to say, I can find the probability of various independent events. So, first thing, events are independent events if the occurrence of one does not affect the outcome of the other. For example, like if you're flipping a coin, if you flip heads the first time, that has no impact on whether you're going to flip heads or tails the next time. So those would be independent events. Okay, for independent events, the probability of A intersect B happening is the probability of A times the probability of B. Okay, and I'll show you some examples here of that. Okay, so a coin and a six-sided die are tossed simultaneously. Determine the probability of getting tails and a 5. So if we're doing that, here's the tails, all the stuff that are tails, and then here is the 5, right? So it says you got to get tails and a 5. So really it's just this one piece right here, right? So that is just 1 out of the 2, 4, 6, 8, 10, 12 different possible events that could happen, right? So that's 1 out of 12. Excuse me. So another way to do that is, from what we were just talking about, is you can multiply the probability of each thing if they're independent events. So a coin, probability of getting tails on a coin is 1/2. And then the probability of getting a 5 on a die is 1 out of 6. 1/2 times 1/6 is 1/12. Okay, so you can do that either way. You can do it with a little two-dimensional table, or you can multiply the events. Okay, so whatever works for you. Okay, getting heads and an odd. So here's heads, and then we also have all the odds, which are here, here, and here. So it's since it's and, they have to both have happened. So that's 1, 2, it's these 3 out of 12, which is 1/4. Or again, you can take the probability of getting heads, 1/2, times the probability of getting odd, which is also 1 out of 2, because it's 3 out of 6, which reduces down to 1/2, and that gives us 1/4 as well. Okay, getting heads or tails, so either one of these, right? So we can get heads or tails, and getting a 4. So that's these. Should have included that in there. Sorry. So heads or tails and a 4. So these both have to happen. So this is going to be our 2 out of 12, or 1/6. So getting heads or tails is a 1. Getting a 4 is 1 out of 6. 1 times 1 out of 6 is 1/6. Okay. Getting tails, so here's tails, and a 1, 2, 3, 4, or 5. So that's going to be all of these. And it does say and, so it has to be both. So it's 1, 2, 3, 4, 5 out of 12. So getting tails is 1/2, and then getting a 1, 2, 3, 4, or 5, that's 5 out of 6. Multiply those together, and there's our 5/12 there as well. Okay, next example. Example 15. Sam likes to cruise around town in his motorized big wheel, or sometimes his motorized couch. Let's see. His big wheel only starts 55% of the time, and his couch starts 75% of the time. Find the probability that they both start, neither start, or only the big wheel starts. So, this one here, I think this is going to be an easier one if we make ourselves a tree diagram. So let's do that for this. Okay, so here's the big wheel, and it starts or doesn't start, and then here's the couch, start or doesn't start. Okay. So it says that his big wheel only starts 55% of the time. So if it starts 0.55. So that means 1 minus 0.55 gives us 0.45. That means 0.45, 45% of the time it doesn't start. Okay. Now the couch and the big wheel, it shouldn't have any impact on the other starting. So these would be independent events. So the couch, it says that the couch starts 75% of the time, 0.75. 0.75. So then if we do 1 minus 0.75, that gives us 0.25. So that means 25% of the time the couch doesn't start. Okay? So once we have this should make our solving these problems a lot easier. So what's the probability that they both start? So here we go. We got start and start. That's these two. So that's 0.55 times 0.75. Right? So they both start. Multiply that out. Nope, that's not it. That's this. Sorry, let's see. We got 0.55 times 0.75. And that gives us 41.3% of the time that they're going to both start. Okay, probability that neither one of them are going to start is doesn't start and doesn't start. So that's going to be 0.45 times 0.25. So here's our 0.45 times 0.25, and that gives us 11.3% of the time. Oops. Here we go, 11.3% of the time. Neither one of them start. And then the probability that only the big wheel starts, so that would be start and then doesn't start for the couch, that's going to be 0.55 times 0.25. Right, so we can pull our calculator back up. 0.55 times 0.25 gives us 13.8% of the time that only the big wheel starts. Okay? All right, got one more example, but before we do that, let's do a quick comedy break.
When you get on an escalator, do me a favor, just grab the handrail and just stand there. Let life take over. Let it raise you from one floor to another. Can't stand the people who still feel the need to walk. Same idiots always. It's usually the guy with the NutriBullet full of greens. That guy just, excuse me! On the left, excuse me, excuse me. I don't let him by. I get all big. I'm like, nope, not happening, no. No. Excuse me, nope, not happening. Big man Pilates time.
All right, let's take a look at our last example here. Example 16, Becky has 2 bags with jelly beans, and then bag A has 3 Dirty Jim Socks jelly beans and 2 Morning Breath jelly beans in it. Bag B has 1 Dirty Jim Sock jelly bean in it and 3 Morning Breath jelly beans in it. Becky draws a jelly bean from each bag. Find the probability that she draws all these different lovely things. Okay, so let's see what we can do to figure this out. On here, I'm just going to draw a tree diagram just so we can see what's going on. You don't have to, because you can actually just go through and calculate each one of the probabilities separately without the tree diagram, but I just feel the tree diagram makes it easier to explain and understand. So let's put that on here. Okay, bag A has, let's see, 3 Dirty Jim Socks jelly beans and 2 Morning Breath. So let's see, that's going to be 3 out of 5 for this one, and then 2 out of 5 for the Morning Breath one, right? And then in bag B, 1 Dirty Jim Sock and 3 Morning Breath. So that's going to be Jim Sock 1 out of the 4, and that's going to be 3 out of the 4. 1 out of the 4, 3 out of the 4. Again, you do not have to set it up like this. I find it easier because then I just follow along figure out which ending I want to have, and I just multiply my branches together. Okay, so probability of getting 2 Morning Breath jelly beans. So that is Morning Breath, Morning Breath. So that's going to be this set of tree branches right here. So that is 2/5 times 3/4. Right? So let's see, that would give us 6/20 or 3/10, right? Or 30%. Probability of getting 2 Dirty Jim Sock jelly beans. So Dirty Jim Sock, that's going to be this one here. So that's 3/5 times 1/4. 3/5 times 1/4 is going to give me 3 out of 20. Okay? A morning breath from bag A, that's this way, and a dirty gym sock from bag B. So then that would be dirty gym sock. So that'd be 2/5. That's this path right here. 2/5 times 1/4. 2/5 times 1/4 gives us not tenths, but 20ths, right? Which is 1/10. Okay. And then what's the probability of getting one of each? I'm going to change colors here just because this is going to be a little different. So that would be a gym sock and a morning breath. So that would be this one here. Or you could get morning breath and gym sock. So we would get either one of these two here. So that would be 3/5 times 3/4. 3/5 times 3/4, right? Or means we would add this probability to the probability of getting the other one, which would be 2/5 times 1/4. 2/5 times 1/4. Okay, so that gives us what, 9/20ths plus, that's going to be 2/20ths, which gives us 11/20ths on that one there. Okay. That's all there is here for the notes on independent events. If you have any further questions, please feel free to ask in class. Thanks.